Outside we have a Train 40-ton chiller, and the chiller is located outside, and we've got our refrigerant lines coming to a remote evaporator. We're using a flat plate heat exchanger as our evaporator. So we got our two liquid lines entering in the TXV. So this piping here would be the beginning of our evaporator. So then we have a refrigerant to water heat exchanger. So we have pumps that are moving water through the heat exchanger here. We got two refrigerant circuits, and each circuit has two compressors. So this would be a 4-stage unit. First thing I had found when I came out here is we've got a stage controller here that stages on each stage of cooling required. I did find that we had an incorrect resistor installed in it that was telling this controller that it was only a 2-stage unit. So we had to order in some resistors and install this 401 ohm resistor here to tell this controller that we have 4 stages. So for the years that this was installed, maybe about 5 years, we've got 2 compressors that have never run on it. But before we were able to enable those compressors, also since it was installed, we're having problems with this Freezestat tripping. So this would be from the outlet water, and we do have water, not glycol. The outlet water from this heat exchanger was getting down close to the freezing mark and tripping this reset. First few times I came out here, everything was working great. Never seen anything below 40 degrees. It was always on a hot day. It wasn't until I was finally out here on a cool day that I found that I was running with an outlet water temp, pretty consistent, 40, 41 degrees. Suddenly, it started dropping off. So I had to determine why on a mild day would I go from 40 degrees down to our Freezestat trip of about 35 degrees. And that happened quicker than that stage controller was able to stage this unit down. So we've got 3 pumps here. These 2 pumps here are lead lag operated, so only one of these pumps need to run at a time. And these are our main loop pumps. So this here would be our supply, so the discharge from the pump, and that's going to head around the building to numerous air handlers. And then we loop back on the return. Here's our air separator. We come back on the return line. And this pipe here heads to the return to the pumps. But then this pump here would be just for our heat exchanger. So this pump, this is the return line here, is drawn from our main return line down into that pump. The discharge of that pump into this flat plate heat exchanger, and out of the flat plate heat exchanger, then that's going to go to the returns for the main loop pumps. So I figured we had to have some kind of flow problem, and being on a milder day, these are our air handlers that have chilled water coils and hot water coils in them. Being on a milder day, a lot of these coils weren't going to be calling for a chilled water flow. So our actuators are shutting off. So I was wondering if we had maybe a lack of a bypass at the end of the loop, but somehow our flow was pretty much stopping. So we were deadheading our flow for some reason. So I walked our piping down here. and found at that time, this is the end of the run. So this is our chilled water supply, and this is our chilled water return. So right now we've got a bypass here at the end of the loop. So should all these air handlers that we just walked by start to close their chilled water actuators, their valves, we're still going to have some flow through the system. The chiller is going to chill that water pretty quickly, but it should have enough time to stage down before we head off on Freezestat. So I had found at that time this bypass circuit wasn't installed. So we just had two caps at the end of this. So when all the actuators shut down, we basically had no flow through the system. So we were contracted to come out and install this bypass circuit. So per their control system here, as their differential pressure transducer here senses that enough valves are closed to where we don't have any flow, we're going to start modulating this bypass open. And to prove to the value of looking through your blueprints, being familiar with piping and ductwork on the blueprints, I did find the original blueprints from when this wing of the school was added, and found that sure enough there was supposed to be a valve there. Of course, it's been too long to really go back on the contractor that installed the piping at that point, but they did just want to eliminate the problem, so they contracted us to just go ahead and install that bypass. And since then, no Freezestat, and then we were able to enable the two compressors with that other sensor, or that other resistor, to get all four circuits working. So everything's been working great since.